guys, probability. Let's just go through a few of these questions and you'll eventually see that they're all very similar to one another, okay? Every morning, Samath has 1 glass of fruit juice with his breakfast. He chooses at random orange juice or pineapple juice or mango juice. The probability that he chooses orange juice is 0.6. The probability that he chooses pineapple juice is 0.3. Work out the probability that he chooses mango juice. Alright, so we know the probability he chooses orange juice is 0.6. Probability he chooses pineapple juice is 0.3. And we're trying to find the probability that he chooses mango juice. Now, whenever we do probability is always on a scale from 0 to 1. If it's a decimal, or 0 to 100%. We're doing percentages. In this case, we're doing decimals, okay? So we're going to focus on decimals only. Now, what does it mean to have a 0 probability? That means something is impossible. If today is Friday, there's a 0 probability that tomorrow will be Monday. It's impossible. And 1 means certain. There's certainly going to happen. If today is Friday, there's a certain chance that tomorrow will be Saturday. Now, so basically, we know the probability of him choosing orange juice is about 0.6. So it's more than half chance. Pineapple is 0.3, so it's less than half chance, because half chance is 0.5. And we've got to find the probability of mango. Alright guys, to do this, there's one really important fact you have to know. All probabilities must add to 1. Because he will definitely choose orange, pineapple, or mango. So we know all these 3 numbers must add up to 1. So 0.6 plus 0.3 is 0.9. 0.9 plus 0.1 is 1. So that's the probability of choosing mango, 0.1. Whenever we do probabilities, you can always give it in 3 ways. Like I said, you can give it as decimals, percentages, or fractions. Okay, so in this question there are decimals. If you want, you can always change this into a fraction. So 0.1 is 1/10 or 10%. So you can give your answer 3 ways, okay? But I just chose decimal because they gave the question in decimals. Now, there are 30 days in April. Work out an estimate for the number of days in April in which Samath chooses orange juice. Well, as we know, the probability of Samath choosing orange juice is 0.6. So every day, there's a 0.6 chance that he chooses orange juice, and he's going to do this experiment 30 times. So we're going to do 0.6 times 30, which is 18. So out of 30 days, there will be approximately 18 days where he chooses orange juice. If it was pineapple juice, we just do 0.3 times 30. If it was mango juice, it would be 0.1 times 30. So you just get the probability and times it by the number of times he's repeating this experiment. In this case, it was 30 days. Next question, guys. Stephen has a biased 5-sided spinner. He spins the spinner 80 times. His score each time is a number that the spinner lands on. The table shows information about his scores. So we basically always first understand the table. So he spins a 1 5 times, a 2 12 times, a 3 16 times, so on. I'm not going to do a probability question. Stephen is going to spin the spinner once more. Use the information in the table to find an estimate for the probability that the spinner will land on an even number. So if Stephen wants to land on an even number, he has to either roll a 2 or a 4. Well, since he rolled a 2 12 times and rolled a 4 32 times, let's add those together. So in total, he rolled an even number 44 times out of, what's the total frequency? 80, it tells us. So he spent an even number 44 times out of 80. And so that's his probability, okay? Next one. There are only white counters, blue counters, and red counters in a bag. Charlie takes at random a counter from the bag. The probability that he takes a red counter is 1/12. The probability that he takes a white counter is 3 times the probability he takes a blue counter. Work out the probability that Charlie takes a blue counter. Alright, so let's draw a little table. So there's a counter and a probability. We know the probability of a red counter is 1/12. And we're trying to find out the probability of a white counter and blue counter. Now, we know that the probability that he takes a white counter is 3 times greater than the blue counter. So in this part here, we're going to have to do some expressions, okay? So what I do first is I say, okay, which has a lower probability, blue or white? Well, since white is 3 times more than blue, blue has a lower probability. So I'm going to call the probability of blue X, okay? And now, the probability of a white counter is 3 times more than the blue counter. Well, if the blue counter is X and white is 3 times more, it'll be 3X, all right? And then, like before, all probabilities must add up to one whole. So we can say 1/2 plus 3X plus X equals 1 whole. Let's simplify it. 1/2 plus 3X plus X is 4X equals 1 whole. So 1/12 plus something is 1. Well, I know 4X must be 11/12 because 1/12 plus 11/12 is 1. So we can write 4X must be 11/12. And let's go find X. Well, to get X by itself, X is being multiplied by 4, so we're going to divide by 4. Divide 4 here, divide 4 here. Let's cancel out. X is equal to 11/12 divided by 4. If this is a fraction, let's turn 4 into a fraction. To turn any whole number into a fraction, it'll be 4/1. Then to divide fractions, you keep the first fraction the same, turn the division into a multiplication, and flip the second fraction, so 1/4. And top times top, bottom times bottom. X is 11 out of 48. All right, and that's how we do it, guys. Next, a box contains some colored cards. Either card is blue or red or yellow or green. The table shows a probability of taking a red or a blue or a yellow card. George takes at random a card from the box. Work out the probability that George takes a green card. Well, we know all probabilities add up to one whole. So 0.3 plus 0.35 plus 0.15 add up to 0. You can use your calculator, but 0.8. So green must be 0.2 because 0.8 plus 0.2 is 1. George replaces his card in the box. Anish takes a card from the box and replaces the card. Anish does this 40 times. Work out an estimate for the number of times Anish takes a yellow card. Well, we know the probability that Anish takes a yellow card is 0.15. And he takes a card 40 times. So we're just going to do 0.15, the probability of getting a yellow card. We're going to do the experiment 40 times, and we're going to get our answer, okay? Shoot, what is that? I think that is, I think that's 6. 6 times. But, let me get my calculator, 1 sec. Boom. 0.15 times 40 is 6, correct. All right, John throws a biased coin 120 times. It shows heads 90 times. John throws the coin once more. Work out an estimate for the probability that the coin shows tails. Well, we know John threw a coin 120 times and heads was 90. So we know the probability of getting a heads is basically 90 times out of 120. So tails should be, well, if he threw heads 90 times out of 120, he must have thrown tails 30 times, the remaining number of times. So we can say 30 out of 120. And we can simplify that to 3/12, and we can divide both numbers by 3, so 1/4. That's his chance of getting a tails. Carly throws the same coin 200 times. Work out an estimate for the number of times the coin shows tails. So the probability of hitting tails is 1/4, and he does this experiment 200 times, so we're going to times it by 200, is 50. So 50 tails. Next page. Ooh! Sample space diagrams. 2 fair 6-sided dice are rolled. The numbers on the 2 dice are multiplied together to give a score. Complete the table to show all the possible scores. Alright guys, the diagram they've given you is something called a sample space diagram, okay? In some questions like this, they're nice and they tell you to use a sample space diagram. in some questions, they give you a question, but they don't give you a sample space diagram. You have to deduce that you have to do a sample space diagram by yourself. Now, when do we use a sample space diagram? Well, we use it to find all the outcomes from only two events where each outcome So we use a sample space diagram, guys, to find all the outcomes from only two events where each outcome has an equal chance. In this question, we can draw a sample space because we're trying to find all the outcomes from two events. We're rolling a dice 2 times. And when you roll a dice, there's an equal chance of getting each of the numbers, okay? The chance of you getting a 1 is the same as a 2. The chance of getting a 2 is the same as a 3, and so on and so forth, okay? And it helps us find all the outcomes from two events. So let's say we're flipping 2 coins. I can do a sample space diagram to see all my outcomes. So flip 1 and flip 2. When you flip a coin the first time, you can get a heads or tails. And when you flip a coin a second time, you get heads or tails. And we're going to add it like this. And now we can find all the different combinations. We can get a heads and a heads. So 2 heads in a row. You can get a tails and a heads. You can get a heads and a tails. And you can get a tails and a tails. So we're able to see all the different ways, all the different outcomes of rolling 2 dice. So, 2 coins. And now it works the same way here. So 2 fair 6-sided dice are rolled. The numbers on the 2 dice are multiplied together to give a score. Complete the table to show all the possible scores. Well, so he rolls a dice, he gets a 1 on the first dice, and he gets a 1 on the second dice. And we're going to multiply his scores together. So 1 times 1 is 1. 2 and then a 1, so we're going to multiply that. 2, and we're going to do everything. So 4 times 1, 4, 5, 6. 1 times 2, 2 times 2, 6, 8, 10, 12. 1 times 3, 2 times 3, 3 times 3. 4 times tables. $30, and then a 6, and then a 6 you get 36. So we've found all the possible outcomes or scores you can get from rolling 2 dice and then multiplying the scores. So now we have to find the probability of scoring a 12. So all I'm going to do is I'm going to find all the 12s in my table. So 12 here, 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 and here. So there are 4 12s. There's 4 possible ways to get 12 out of how many ways in total? Well, let's count all the boxes. So we can just go, there's 6 across by 6 up. That's a faster way. So 6 times 6 is 36. There's 36 possible combinations, okay? Now, find a probability of a score of 10 or more. All right, so we're going to circle all the boxes which give us a score of 10 or more. So these 2 boxes, 3 boxes, 10, 10 or more, 10 or more. So let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19. All right, there are 19 ways of getting 10 or more out of 36. Find a probability of an even number. So we're going to circle all the even numbers. So, there's a lot. All of these. All of these. How many is that? 1, 2, 3. Plus 6 is 9. 10, 11, 12. Plus 6 is 18. 13, 18. 19, 20, 21, plus 6 is 27. So there's 27 out of 36 chance of getting an even number. All right. You know what, guys? These ones you can practice by yourself. Oh, no. Let's just keep going. We'll do all of them together. All right, a box contains 40 cards. Remember, guys, actually, you can always just pause the videos whenever you want and just do the questions by yourself. A box contains toy cars. Each car is red or blue or black or silver. Emily takes at random a car from the box. The table shows the probabilities that Emily takes a red or blue or black car. Work out the probability that Emily takes a silver car. Well, we know all probabilities must add up to one whole. Oh, oops. So 0.2 plus 0.05 plus 0.15 add up to 0.4. So this has to be 0.6. Now, Emily puts the car back into the box. There are 6 blue cars in the box. Work out the total number of cars in the box. So we know there are 6 blue cars in the box, and we're trying to find out how many cars are there in total. Well, we know that 6 cars gives us a 0.05 chance of getting a blue car. And we want to find out how many cars are in total to give us a probability of 1, because 1 means certain chance. That means all the cars, okay? Well, what I do is I say, okay, 6 cars equals 0.05. I want to find out the total number of cars, which is a probability of 1. So I just think proportionally. How do I get from 0.05 to 1? Well, I know it's pretty obvious it's times by 20. But if you're having a hard time, you can just go backwards. You can do 1 divided by 0.05. Which is 20. So yeah, times 20 here. Need times 20 on the other side. 6 times 20 is 120. Alright? So we know there are 120 total cars in the box. Another way is you can think of it in terms of fractions. 6 cars is equal to 0.05. I'll turn to a fraction. 0.05 as a fraction is 5 100ths. So we know 6 cars is 5 100ths of the total box of cars. So now, in order to find all the cars, I need to find 100 100ths, which is just one whole. So from 5 to 100 is times 20. See times 20 here, which is 120. All right. This one you can do by yourself. We've kind of done this a few times. 2 bags, 1 and 2, each contain counters that are equal size. Bag 1 contains a pink counter, a green counter, and yellow counter. Bag 2 contains 2, 3, 4, 5 counters. A counter is drawn at random from bag 1, and a counter is drawn at random from bag 2. If the counter from bag 1 is pink, the number on the counter from bag 2 is doubled. If the counter on bag 1 is green, 1 is added to the number on the counter of bag 2. If the counter from bag 1 is yellow, the number on the counter from bag 2 stays the same. Complete the table to show all possible scores. All right, so let's say we go to bag 1 and we pick out a pink, okay? Pink means the number on the counter from bag 2 is doubled. So if we pick up a pink and then we pick up a 2, we're gonna double 2 to make 4. If we pick up a pink and pick up 3, pink means double, so we're gonna double 3 is 6. Pink and then 4, we're gonna double 4 is 8. Pink and then 5, we're gonna double that score to make 10. Now let's say this time in bag 1, we choose a green counter, okay? Green means we add 1 to the counter from bag 2. So we pick a green and then a 2, we're gonna add 1 to 2, which is 3. Green and 3, we're gonna add 1 to 3 to make 4. Green and 4, we're gonna add 1 to 4 to make 5, and then 6. Now, yellow. If the counter from bag 1 is yellow, the number on the counter from bag 2 stays the same. So yellow, let's say I pick a yellow first and then a 2 from the second bag, this score just stays the same, so it'll just be 2, because yellow means the score just stays the same. So 2, pick a 3, 3, 4, 5. Now, find the probability of scoring a multiple of 3. Multiple of 3 just means the 3 times table. So all you're going to do is look at your sample space diagram and see all the 3 times tables. So let's have a look. Well, 1, 2, 3, 4. So there's 4 multiples of 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 outcomes in total. This one, 2 fair 6-sided dice are thrown. The total is the sum of the numbers that each dice lands on. Work out the probability that the total is 4. Alright, so how can I solve this? So I roll 2 dice, and I add up the numbers on the dice, and I gotta find a probability that the total is a 4. Well, maybe I can use a sample space diagram to see all the different outcomes from rolling 2 dice. And how do I know I can use a sample space diagram? Because I look at this criteria. Find all the outcomes from only 2 events where each outcome has an equal chance. Well, in this case, there are 2 events. I'm throwing 2 dice. And when you throw a dice, the probability of scoring each number is exactly the same. You're just as likely to score a 1 as you are to score a 6. So let's draw a sample space diagram to see all the different possibilities when you roll 2 dice. So throw number 1, throw number 2. When you throw the first time on a dice, you can get a 1, 2, 3, 4, 5, and 6. When you throw the dice the second time, same thing. You get 1, 2, 3, 4, 5, 6. And then what's happening? When you throw the dice the first time and you throw the dice the second time, we sum the numbers, okay? So we're gonna, first I'm gonna make these lines. So let's say I roll a 1 and then a 1. Now, to find the total we're gonna sum the numbers. So 1 plus 1 is 2. Let's say I roll a 2 and then a 1. So that's gonna be 3. So we're just gonna add the numbers. 4, 5, 6, 7. I'll change color actually. Three, 4, 5, 6, 7. And I'll show you a faster way of doing this than using a sample space diagram. So these are all the possible scores we can get from throwing 2 dice and then adding up their scores. And we're trying to find a probability that the score is 4. So let's just circle all the 4s. 1, 2, 3. That's it. Oh, so there's 3 out of, in total, well, there's 6 across, and there's 6 up. So there's 36 numbers in total, so 3 out of 36, okay? There's another way of doing this question, guys. It's called, I don't know what it's called. Maybe it's called the desirable outcome method. Instead of drawing the sample space diagram and finding all the outcomes, let's just think of the only ways I can score a 4. Well, the only ways I can score a 4 on a dice is I can get a 1 and a 3, a 2 and a 2, and a 3 and a 1. It's pretty easy just to think of all the different ways you can score a 4. So I know there are 3 ways. So 1 and a 3, 2 and a 2, and a 3 and a 1. Now what I do is I use a little bit of math now. We're going to be doing this later, so don't worry. What's the probability of rolling a 1 on a dice? Well, it's 1/6. What's the probability of rolling a 3 on a dice? Well, it's also 1/6. Whenever you're trying to find a probability of 2 events happening, we're going to multiply these. So 1/6 times 1/6 is 1/36. Same thing here. What's the probability of rolling a 2 on a dice? Well, it's 1/6. What's the probability of rolling a 2 on the second dice? Well, it's also 1 out of 6. And to find a probability of getting a 2 and then a 2, we're going to multiply, okay? So 1/6 times 1/6 is 1/36. And then, what's the probability of rolling a 3 on a dice? Well, it's just 1 out of 6. What's the probability of rolling a 1 on a dice? Well, it's just 1 out of 6. So the probability of rolling a 3 and then a 1 is multiply. So 1 out of 36. So we either want this outcome here, or this outcome here. So we're going to add up these 3 fractions, all right? And 1/36 plus 1/36 plus 1/36 is 3/36. So this is another way of solving this problem, okay? Writing down all the outcomes that add up to 4, finding the probability of 1, finding the probability of 3, multiplying them, and adding up the 3 answers you get, okay? Next, boom, you can do this one by yourself, you can do this one by yourself. Yeah, and we'll move on to some harder stuff now. So now we're going to make things a bit harder by looking more at multiple event questions, such as like flipping 3 coins, playing 2 football matches, and things like that. All right, and we're going to look at the idea of probability trees. All right. Before we start looking at some practice questions, let's look at the question I've just made up. Bob flips 3 coins. What's the probability of rolling exactly 2 heads? All right, guys, there are 3 ways where I think we can solve this problem. First way is that since when you flip coins, the probability of each outcome is always the same, we can write down all the different ways we can flip 3 coins. So one way is we can get a heads, heads, heads. We can get a heads, tails, heads. What else? We can get a heads, heads, tails. Heads, tails, heads. Tails, tails, heads. Tails, heads, tails. Heads, tails, tails, and tails, tails, tails. So there are 8 ways, and each of these outcomes have an equal chance. You're just as likely to get a heads, heads, heads as a tails, tails, tails. And let's circle which ones give us exactly 2 heads. Well, this one, and this one. So it's 1, 2, 3, 3 out of 8 chance, okay? That's one way. So we basically just drawn a sample space diagram and listed out all the different ways of getting, all the different outcomes of flipping 3 coins, okay? This way only works though when the outcome of each of these scenarios is exactly the same, okay? So I don't recommend using this method at all. Another way, guys, is by just using something called just the desirable outcome method, all right? So in this case, we're pretty much doing what we did in the last question. We're pretty much doing what we've done here, but I'm only writing the outcomes which satisfy exactly 2 heads. So the only ways of getting 2 heads are heads, heads, tails, heads, tails, heads, and tails, heads, heads. And what you're going to do is we're going to look at this first one only, heads, heads, tails. And I'm going to say, okay, what's the probability of getting a heads? Well, it's 1/2, 1 out of 2 chance. What's the probability of getting a heads the second time? Well, it's also 1/2. And what's the probability of getting tails the third time? Well, still 1/2. Now to find the probability of getting a heads, and then a tails, we're going to multiply the probabilities. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. All right. Now let's do the second one. What's the probability of getting a heads the first time? Well, 1 out of 2. How about tails the second time? Well, still 1 out of 2 chance. And heads the third time? Well, we flip a coin. What's the probability of getting a heads? Still 1 out of 2. We're going to do the same thing. Multiply them. That's going to be 1/8. And then same thing here. Well, tails the first time is 1/2. Heads the second time is 1/2. Flipping a heads the third time is 1/2. Times them, 1/8. And what you do to combine these is we add them together. So 1/8 plus 1/8 plus 1/8 is 3/8. And this is my favorite way of solving multiple event questions, okay? A third way of doing it, guys, is called a probability tree, okay? And here's what we do. I'll make all this smaller. We can do a probability tree. So we're going to first write down the 3 events on top. So there's flip 1, flip 2, and flip 3. So we have a starting point. All right, so this is the start point. And we're going to flip a coin. All right, when we flip a coin, there are only 2 outcomes. We can get a heads or a tails. Sometimes there's going to be 3 outcomes like this. Like if we're playing a football match, there's win, draw, and loss. But in this case, when you flip a coin, it's just heads and tails. What we're going to do is we're going to write down the probabilities of getting a heads and or a tail. So when you flip a coin, the probability of getting a heads is 1/2. One sec. Is 1/2. And the probability of getting a tails is 1/2. Then let's say we get a heads the first time, all right? Then we flip a coin again. But when we flip a coin, it's still heads or tails. The probability of getting a heads is still 1/2. The probability of getting a tails is still 1/2. And the same thing here. Let's get a tails the first time. We flip a coin again. We can get a heads or tails. Probability of heads is 1/2 and 1/2. We're going to flip a coin the third time, so we can get a heads or tails. 1/2 and 1/2. Heads or tails. 1/2 and 1/2. Heads or tails. 1/2 and 1/2. And tails, tails, flip it one more time. We can get a heads or tails. 1/2 and 1/2. Since all the probabilities are the same, we probably didn't have to write down 1/2 so many times, okay? So that's step one. We draw our tree. Now, we have to find the probability of rolling exactly 2 heads. So now you have to highlight all the ways we can get 2 heads. So one way is we can get a heads, and then a tails, okay? So heads, and a tails. So we're going to write down those 3 probabilities. 1/2, 1/2, 1/2. And to combine them, we're going to multiply them. So 1/2 times 1/2 times 1/2 is 1/8. Or we can get a what? Heads, tails, heads. So 1/2, 1/2, 1/2 again. So heads, tails, and heads. So we're going to multiply them to get 1/8. And the final way is we can get a tails and then a heads and a head. So 1/2, 1/2, 1/2 again. And we're going to multiply them to combine them. 1/8. And then you're going to add them together. To combine these 3 answers, you're going to add them. So 1/8 plus 1/8 plus 1/8 is 3/8. So here are 3 ways you can answer this particular question, guys. You can write down all the outcomes. This only works when the probability of each outcome is the same every time, so I don't really recommend this method. I like the desirable outcome method. I just write down all the ways I can get 2 heads, write down the probabilities, multiply them and combine them, or you can do a probability tree. So now you know what a probability tree is. Let's hop onto these questions, okay? Alan has to attend a meeting on Monday and on Tuesday. The probability that he is late for a meeting is 1/8. Complete the probability tree diagram. So here's a start point. Alright, the probability that he's late is 1/8. So the probability that he's not late must be 7/8, because all probabilities must add up to 1. Alright, so 1/8 plus 7/8 is 1 whole. Then, on the next day, well, you can either be late or not late again. And the probability of being late is still 1/8. Probability of not late is 7/8. Now let's say on Monday he is not late. On Tuesday he can be still late or not late. So late is 1/8. Not late is 7/8. Now, calculate the probability that Alan is late for at least 1 meeting. So what we're going to do is we're going to highlight the paths where he's late for at least 1 meeting. So here's the first path, late and late. That's at least 1 time he's late. So we're going to write 1/8, 1/8. To combine them, we're going to multiply them. So we're going to 1/8 times 1/8 is 1/64. Then another way you can be late at least once is late and not late. He's late, that's at least once. So let's combine these two. 1/8 and 7/8. 1/8 times 7/8 is 7/64. What's another way he can be late at least once? Well, not late and late. He's at least late once there. Let's combine that. So 7/8 times 1/8 is 7/8 is 7/64. And then now we have to combine these answers by adding them. So 1/64 plus 7/64 plus 7/64 is 15/64. Okay? And that's how you use a probability tree to help you solve this problem. Alright? Next page. Bill and Joe play some games of table tennis. The probability that Bill wins the first game is 0.7. When Bill wins a game, the probability that he wins the next game is 0.8. When Joe wins a game, the probability that she wins the next game is 0.5. The first person to win 2 games wins the match. Complete the probability tree diagram. So, I know in the first game, the chance Bill wins is 0.7. So the probability that Joe wins must be 0.3. Because 0.7 plus 0.3 is 1 whole. Now, when Bill wins a game, the probability that he wins the next game is 0.8. So if Bill wins the first game, the probability that he wins the next game is 0.8. So this is 0.8. So therefore Joe is 0.2 because they have to add up to 1. If Joe wins a game, the probability that she wins the next game is 0.5. So 0.5, the probability that Bill wins must be 0.5 because 0.5 plus 0.5 is 1. All right? Now, let's say Joe wins again. The probability that if Joe wins, the probability that she wins the next game is 0.5. So Bill must be 0.5. And then here, Bill wins. If Bill wins a game, the probability that he wins the next game is 0.8. So this is 0.8. And Joe is 0.2. Okay. The first person to win 2 games wins the match. So let's go ahead and highlight ways that Bill wins the match. So in order to win the match, he has to win 2 games. So what are some ways that Bill can win 2 games? Well, he can win and then win. So 0.7, 0.8. How do we combine them? We multiply them. So 0.7 times 0.8 is 0.56. What's another way he can win? Well, he can win, then Joe can win, and he can win again. So that's 2 ways he can, that's a win and a win. That's 2 wins. So you're going to combine these 3. So 0.7 times 0.2 times 0.5, which is 0.07. What's another way he can win? Well, here. He loses the first game, but he wins the second and wins the third. He's won 2 games there. So let's combine these 3 probabilities. So 0.3 times 0.5 times 0.8. 0.3 times 0.5 times 0.8 is 0.12. So now, once you have these 3 answers, you add them together. So 0.07 plus 0.56 is 0.75. You've got a 0.75 chance of winning all 3 games. Of winning the match by winning 2 games. Next question, guys. So sometimes they'll give you a question where you may or may not have to use a probability tree. You have to figure out if you should use one or not. Here are 7 counters. Each counter has a number on it. Ali puts the 7 counters in a bag. He takes at random a counter from the bag and does not replace the counter. He then takes at random a second counter from the bag. Calculate the probability that the number on the second counter is 2 more than the number on the first counter. So in this question, there is more than one event. He takes a counter and a second counter. So since there's more than one event, we could probably draw a probability tree, okay, to do this question. But honestly, you don't need to. I like to use something called the desirable outcome method, okay? I'm just going to write down all the ways to satisfy this criteria, where the number on the second counter is 2 more than the number on the first counter. In what kind of ways can we get in what outcomes is the second counter 2 more than the first counter? Well, I can only see one way. You can get a 2 on the first counter and 4 on the second counter. If he gets 2 on the first counter, 2 more than that is 4. Is there any more ways you can get 2 more on the second counter? No, that's it. So now we're going to find the probability of getting a 2. So the probability of getting a 2 is just 1 out of 1, 2, 3, 4, 5, 6, 7. Now here's the thing. Ali puts his hand in the bag and picks up a 2. So now the 2 is gone. It's not there anymore. So what's the probability of getting a 4 now? Well, it's 2 out of, well, there's only 6 counters left. 6. To combine them, we're going to multiply them. So it's going to be 2 out of 42. And that's your answer, okay? So all you have to do here, guys, is write down the only way you could satisfy this criteria, where the second counter is 2 more than the first counter. There's just 2 and 4. That's the only way where the second counter is 2 more than the first counter. Find 2 probabilities and multiply them, okay? Next one. The number on the second counter is 1 more than the number on the first counter. So let's use our desirable outcome method again. Let's write down the only ways where if a number in the second counter is one more than the number in the first counter. Well, one way is you can get a 1 and then a 2, because the second counter is one more than the first counter. Or you can get a 4 and a 5. So let's look at this one first, 1 and a 2. So what's the probability of getting a 1? Well, it's 1 out of 7. So let's think about this now. So Ali gets a count, he puts his hand in the counter and gets a 1. So now what's the probability of getting a 2? Well, 1 out of 6 in total. There's only 6 counters remaining. We're going to multiply that, so 1 out of 42. Now let's do this one. So let's start from the beginning again. Ali puts his hand in the bag. What's the chance he gets a 4? Well, 4 is 2 out of 7. So he picks up one of the 4s. Let's say he picks up this 4. What's the probability of getting a 5? Well, there's 3 5s out of 1, 2, 3, 4, 5, 6. Out of 6. 2 times 3 is 6. 7 times 6 is 42. And to combine it, we just add them up. So 142 plus 642 is 742. And this is our answer. I just wrote down the different ways we can get the second counter to be one more than the first counter. So 1 and 2 and 4 and 5. Found the probabilities for each one and then added them together. Last one. Parveen travels to school either by bicycle or by bus. The probability that on any day she will travel by bicycle is 0.7. When she travels by bicycle, the probability that she will be late for school is 0.2. When she travels by bus, the probability that she will be late for school is 0.1. Calculate the probability that on a random chosen day, Parveen will travel by bus and be late for school. So for this question here, I'm going to use the desirable outcome method again. So we have to find the probability that Parveen travels by bus and then is late. So bus and then is late. So what's the probability of taking the bus? Well, if the probability of taking a bicycle is 0.7, the probability of taking the bus must be 0.3, because 0.7 plus 0.3 is 1. So the probability of taking the bus is 0.3. And if he takes, and if he takes the bus, the probability that he's late is 0.1. So the probability that he's late is 0.1. Now to combine them, we just multiply them. So 0.3 times 0.1 is 0.03. And that's our answer, okay? We could also do this question, guys, using a probability tree. I don't know, I just feel it's a bit of a waste of time. In this case, there are 2 events. There's the method of transport, bus or bike, and whether he's late or not late, okay? So let's start from the beginning. So you can either take a bus or you can bike. And if he takes the bus, he can be late or not late. And if he takes the bike, he can be late or not late. So the probability he takes the bus is 0.3. The probability he takes his bike is 0.7. If he takes bus, my bad. If she takes the bus, the probability that she's late is 0.1. So bus, and then she's late is 0.1. So not late must be 0.9. And if she takes the bike, the probability that she's late is 0.2. So bike, the probability that she's late is 0.2. So the probability that she's not late is 0.8. And the question was, what's the probability that Parveen travels by bus and is late? So bus and is late. To combine that, you're going to do 0.3 times 0.1, which is 0.03. So there are 2 different ways to do this problem. Calculate the probability that on a randomly chosen day, Parveen will not be late for school. So let's do our desirable outcome method, okay? So what are some ways Parveen will not be late for school? Well, desirable outcome. Well, he can take the bus and not be late, or he can take his bike and not be late, all right? So what's the probability of taking the bus? The probability of taking the bus is 0.3. And If he takes the bus, the probability that he's not late, the probability that he's late is 0.1. So the probability that he's not late is 0.9. We're going to multiply that, so 0.27. Now let's do the next one. The probability that she takes a bike is 0.7. And if she takes a bike, the probability that she's late is 0.2. So the probability she's not late is 0.8. So we multiply that, is 0.56. And you're going to add those together, 0.83. Here, you can also use your probability tree, okay? Actually, probability tree here would be actually easier. So, calculate the probability on a randomly chosen day. Parveen will not be late for school, so she can take the bus and not be late. So 0.3 times 0.9, which is 0.27. Or she can take the bike and not be late. So 0.7 times 0.8, which is 0.56. Add those together, 0.83. Alright guys, and that is pretty much it for probabilities, alright?